Well, hello. Today we are going to be talking about the first half of Module 3. I'm going to go through some things on here that sometimes students struggle with, just to make sure that you're understanding these concepts really well. And so the first thing that we're going to be talking about is about functions. But before we can talk about functions, we got to know what a few of these things are. So let's talk about a relation first of all. So a mathematical relation is just a set of ordered pairs. So in this relation, it's only made up of 3 different points, right? And the points are 3, 2, -1, 0, and 4, -2. So those are the only 3 points in this relation. All right, now the domain of that relation is the set of all the x values of the relation. So if I'm looking at my x values, remember that I have my x is listed first and then my y is listed second. And we can also think of the domain as input values. So I'm going to write that there as well. And so our x values on each of these are 3, -1, and 4. Those are all of our x values there. And then our y values, let's put that in green here. All right, so our y values are going to be the second number in the point, and so that would be 2, 0, and -2. And I wrote those down here as well. Now, oftentimes when they write out the domain, they'll sometimes put those numbers from smallest to biggest. It's not wrong to not write it in that order, but you might notice on the homework and stuff when they give you an answer that they'll usually write it that way. So they may write it as -1, 3, and 4, but it's still the same answer either way. All right, and also the range, instead of it being the input, it is the output. All right, so on this then, now we have enough information that we can talk about what a function is. So a function is where each element of the domain corresponds to exactly one element in the range. All right, so sometimes students get this a little bit backwards in their mind, and so I want to make sure it's clear to you on what a function is and what it isn't. So let's take a look at a little example here to try and figure out if this relation is a function or not. Okay, so say they give us this relation. So we've got the points 1, 5, 3, 6, 5, 7, and then 7, 6. All right, and so usually I'll ask students, okay, do you think this is a a function or not, given that definition, that each element of the domain corresponds to exactly one element of the range, right? And remember, each of these numbers are the elements of each of them, right? These are the elements of the domain, 3, -1, and 4 on that one. And these are the elements of the domain, or of the range. So the elements of a domain, elements of the range. Okay, and so that's what we're looking at here. And so when we're looking at this, I want to make sure, let's just underline all of our x values here. So we've got 1, 3, 5, and 7. And then our range, we see we have 5, 6, 7, and 6. So we see that the 6's are repeated, all right? And so So there's something going on here, but is this a function or not? Okay. And it actually is a function. Okay, so when we're looking at functions, it's our x values that we need to make sure are unique, right? We can't have repeated x values, but if we have repeated y values, that's okay. So let's put next to our definition of function here that no repeated x values. Oops, x values. Okay, or we call them inputs, right? Our input cannot be repeated. So this is a function, okay? Because my x values are all unique, they're not repeated. Now, sometimes this is kind of hard to remember for students. They're like, okay, well, how do I remember this? So I have a way that I want you to kind of think about as we're doing this next part. And I want you to think about a vending machine, right? And so let's say you went up to a vending machine and you noticed you're trying to decide what you wanted to get. And you noticed if you hit the A1 button, that chips would come out. If you hit the B3 button, then gum will come out. And if you hit the C2 button, then a cookie you will get. And D1 is going to be like a Twix bar or something like that. Okay? So on this, so think about if you hit that A1 button, right, you know what you're going to get. And we know that because like all of these are unique. All of the buttons on that vending machine are unique. Okay? But what if they had a vending machine where A1, you had an A1 button on there, and it was going to chips, right? And then maybe you still have like the B3 is giving you gum. But then you have another A1 button that is giving you a cookie. All right, so if you hit A1 on this vending machine, you don't know whether you're going to get chips or whether you're going to get a cookie. And so this would be something that would be not a function. Okay, so this one is a function because all of our inputs, right, that button that we're pushing is are unique, so that makes it a function, where this one, our A1s repeat, and so that's not a function. Okay, let's think about just one more. You know how there's like some vending machines that you go up to and all they have in them are water. All right, so whatever button you push, you're going to get water. So what do you think about that? Would that be a function or not? Because we have all of these waters are repeated. Right? But remember, our definition is we just don't want repeated x values. So our inputs, again, they're unique. So we know what we're going to get, right? We know any button that we push, we are going to get water. So it doesn't matter that, these waters are repeating of the output. We know what's going to come out of there. Just any button we push is going to give us water. So this also would be a function. Okay? So understanding what functions are and functions are not is going to be really important, not only in this class, but in other math classes as well. You're going to keep building on that idea of functions. Now, the next thing that I want to talk about is something called function notation, because you're going to see this a lot too. So function notation, all right, is where we have something that kind of looks like this. All right, and sometimes when students look at that, they think it says f times x, because we've talked about how when something is in parentheses that it means multiply. But in this context, when we're dealing with function notation, we actually read this as f of x. Okay, so not f times x, but f of x is what we have there. Okay, and so let's take a look at an example if it asks us to evaluate something here. Do a couple of these. Oopsie. So they'll give you some kind of function. So let's say they give us that f of x equals 3x squared minus 5x. And they want us to find f of negative 2. Okay, now remember, this doesn't mean f times negative 2, right? F of negative 2. And this is our x value, right? So this negative 2 here is our x, right? We have it as f of x. And so what we're really going to do is when we're trying to find f of negative 2, we're going to put negative 2 everywhere we see an x, right? So I'll put negative 2 in here, and also I'll put it here. Okay, so let me do this. So when I do that, I get 3 and then times negative 2. I'm going to put this in green just to make sure it stands out to you here. All right, squared, and then minus 5. And then again, in place of x, we're going to put negative 2 in there. And now I just need to simplify that. Okay, I need to get it all simplified. So I need to follow the order of operations when I'm doing this. So order of operations, well, we've got to do exponents before we do multiplication. So that's probably the place where I see most people make mistakes. You've got to raise to the second power first. All right, so let's think about this. Negative 2 squared means negative 2 times negative 2, which actually gives you a positive 4, right? So this is really saying 3 times 4. And then negative 5 times negative 2 is a positive 10. And now we've got this multiplication that we need to do. So we have 12 plus 10, and when we add those together, we get 22. So 22 would be our answer on that one. All right, we're just substituting that in, right? Wherever we see x, we're going to replace those x's with a negative 2. And notice when I took out my x's here, I put the number in parentheses. And that's just a good habit to get into as you're doing this. Just remember, if I take out a variable, put that number back in parentheses so that you don't make a mistake with your signs, because that can happen. All right, let's look at one other one, and this is one that sometimes on the homework students look at and they get kind of confused about. So let's take a look at it. So if it asks you to evaluate again, and this time they give us the function g of x, so it's not always going to say f of x. It could say g of x, it could say h of x, right? So it can be a lot of different things, but this is still a function here. So it gives us 3 minus 4 times the absolute value of negative 2x plus 5. All right, so that negative 2x plus 5 is all in absolute value. And then it wants us to find f of negative 4. Okay, so again, we're going to take that negative 4. All right, so I'm going to put this in green, maybe over here, and make it stand out. All right, so everywhere I see an x, all right, and in this one we only have one, and it's right there, I'm going to put negative 4 in place of it. Okay, so let's see. Now be careful on this. We can't do 3 minus 4 first. A lot of people try and do that. And even on the first exam, or the stuff that was covered with the absolute values in the last chapter, we had some of these, and some people were trying to do that. And you can't do that yet, because remember, this is connected by multiplication. So I really have -4 times this whole absolute value thing. And I've got to do multiplication before I can do adding or subtracting. But I can't distribute that -4 through the absolute value. Remember, these absolute values aren't the same thing as parentheses. Absolute value means the distance away from 0. And so a distance is always positive. So maybe just a little remembering over here of absolute value. If I have the absolute value of -3, it's 3 places away from 0 on the number line. So the absolute value of 3 is -3. The absolute value of +3 is also 3 places away from 0 on the number line. So it's still 3. So the answer to an absolute value is always going to be positive. And so that's why we can't just kind of distribute that through. That's not going to work for us. So let's see, how do we evaluate this then? Well, I'm going to first take my -4 and put it in place of my x. So take out the x, put -4 in place of it. And now I need to follow the order of operations. So order of operations, it starts off with parentheses, right? Then exponents, then multiply and divide at the same time, going from left to right, and then add and subtract, going from left to right as well. So even though I just got done saying these are not parentheses, right? That P in, that we talk about when like PEMDAS or whatever, really the parentheses means more than just parentheses. They mean any kind of grouping symbol. So it could be parentheses, it could be square brackets, it could be little squiggly brackets, right? It could be absolute value. So any of those grouping symbols is really what we're looking for. So we want to simplify what's inside there first. So let's do that. So that means this first part's just going to stay the same. So let's keep that 3 minus 4 out there. Absolute value, well, we need to do our multiplication here first. -2 times -4 is +8, all right, plus 5. And that gives us 13, and the absolute value of 13 is still 13. So I get 3 minus 4, and then, like I said, the absolute value of +13 is still 13, so I can write it like this. Okay? And then I need to keep going here. Got to do my multiplication before I do the subtraction there. And so 4 times 13 is 52, so I have 3 minus 52. And 3 minus 52 is -49. And so that would be my answer on that one. Okay, so hopefully that helps you with some of those questions on your homework. There's some like that tend to be a little bit tricky for you. All right, the next thing that I want to talk about is just about graphing some lines. So if we're doing some graphing of lines, they talk about graphing using x and y intercepts. And so let's first talk a little bit about what an x-intercept is and what a y-intercept is. All right, so an x-intercept is if you have a graph, right, and you have, let's say, so here's just the grid, right? And if I have like doing a different color, a line going through here, right, then where it hits the x-axis, right, where that line is crossing the x-axis, that's our x-intercept. Okay, so the x-intercept is where a graph crosses or touches the x-axis. And so to find x-intercepts, all right, we need to let y equal 0 and solve for x. Okay, so let's think about like this point right here. So when we're talking about ordered pairs, right, we said, okay, well, our x value goes first, and then our y value goes second. So do you see how we're going over a certain amount? Maybe that's 2 or something like that, right? But we're not going up or down any. So our y value is 0. So that's why when we let y equal 0 and solve for x, it's going to tell us that point on the graph that we have there. Okay, and similarly with y-intercepts, right, it is where the graph crosses the y-axis or touches. Both down, touches or crosses the y-axis. Okay, so again, if we looked at this picture up here that we have, and maybe we get a different color here, maybe I'll have like maybe orange. Okay, and so if I'm looking right here, right, that is where it is crossing the y-axis. And so that would be my y-intercept. And so to find these y-intercepts, you want to this time let x equal 0 and then solve for y. Because again, think about this point right here. Right, so this y-intercept here. All right, well, if you're going over, remember, because the first number is how far over we're going. We're not going over any, so that's 0, but maybe this is up 1 or something like that. So, 0, 1 or something like that would be the point. All right, so that's why we're going to let x equal 0 and solve for y. That will give us that point there. Okay, and so they ask us to use this idea to be able to graph some lines. So let's see, let's do an example where it asks you to graph 2x minus 3y equals 6. So if we're thinking about what we're trying to do here, oh, and it says, you know, like using intercepts. So it's telling us how it wants us to graph it. And it's just because it wants us to get used to different ways. It's not wrong if you graph it a different way, but there's reasons why we want you to know about intercepts and what they are. So if we make a table of values here, and we, say, okay, with y is 0, then when we find what x is here, this is going to be my x-intercept. All right, and if I let x equal 0, and then solve to figure out what y is, that will be my y-intercept. So sometimes it might be easier to, think of it that way in a table of values to help you set this up. Okay, so let's look at this. So if I plug 0 in place of y in this equation, I'll have 2x minus 3, I'm going to put this in green so it stands out here, 3 times 0 equals 6. Right? I just replace that y with the 0 here. Okay? And then 3 times 0 is just 0, right? Or negative 3 times 0, so that's gone. I'm just left with 2x equals 6. And then I just need to divide by 2 to figure out what x is. So x equals 3. So that's what I have here. So that's my x-intercept, right? 3, 0. And now my y-intercept, we're going to let, let's see, I'm going to put this here. So this was to figure out our x-intercept. And when you're listing your answers for x-intercepts, Sometimes it'll have you list it like this, but if it says to write it as an ordered pair, then make sure you don't leave your answer like this, right? We're saying, okay, x is 0, and then, or sorry, x is 3, when y is 0 there. Okay, so write it as an ordered pair. And then for the y-intercept, right, same kind of thing. Now we're going to put 0 in place of our x. So 2 times 0 minus 3y equals 6. Again, 2 times 0 is just 0, so that part's gone. And so I'm just left to needing to divide by -3. And so when I do that, I get y equals -2. All right, and now I can write that as an ordered pair, also 0, -2. Okay. So make sure you watch the directions closely. If it asks you to write as an ordered pair, make sure you write it like that. Okay, so now we found those, but we haven't graphed it, which is what it wants us to do. So let's make a little grid over here, and then we'll graph these. So if I, let's see. Okay, and so if I do this, let's see, I'm going to use blue on here. So 3, 0, so over 3 up 0 is here, right? So that's my x-intercept, that's where it's crossing the x-axis. And then my y-intercept is over 0 down 2, so that's going to be here, right? And that's on my y-axis, so that's my y-intercept. And then you can just kind of connect those dots together to make a line. And so that's what you'll do if it's saying to graph using intercepts. Okay. All right. Then also, it asks you to graph things using the slope. And so let's talk a little bit about slope next. All right, so slope, right, kind of talk about slope in different ways. Sometimes, like, we use the letter M to mean slope. Oftentimes when you see M in the equation, not always, but, you know, sometimes it is meaning the slope. But remember, slope is a ratio. It's comparing the rise over the run, right? Comparing the rise to the run. So how far something is going up or down compared to how far it's going left or right. And that gives us the slope of a line. And so if they're giving us 2 points, let's say, all right, so let's say they give us, they're just asking us to find the slope using the slope formula. So let's write our slope formula over here. So slope formula is we have m equals y2 minus y1 divided by x2 minus x1. Right? Because our y's, remember on our graph, right? These are our y's, these are our x's. So y's are what is going up or down. That's our rise, right? And then our x's are what going left to right. So that's our run. So it's really important to remember that it's your y's that are on the top in that slope formula, and remember that. Okay, so let's use this. So we want to find the slope between the points. So find the slope of a line between, right, or containing the points, -4, 3 and 2, -9. So I'm going to put some labels on some of these, all right? So this is an x and a y, all right, x and y, and this is also an x and a y. but we need to be able to, tell the difference between them in our equation. So we just need to say, okay, this is point 1, so I'll call this x1, y1. And this is my second point, point 2, so that's going to be x2, y2. All right, so that's what those little superscripts mean on the bottom there, okay, those subscripts. So let's use this and now put those into the slope formula. So m equals, right, so I'm going to put y2 minus y1, so that's going to be negative 9 minus 3 over, now I need to do my x2 minus x1, so 2 minus a negative 4. So be really careful, make sure you don't write 2 minus 4, it's 2 minus a negative 4. And when you are subtracting a negative, that's really addition there. So I'm just going to change those signs. So if I simplify this on the top, I get negative 12, and on the bottom, I get 6. And then if I divide those, I get negative 2, right? Or negative 2 over 1, if we're thinking of it as the slope. All right, so it's saying it's going down 2 for every one we go to the right, right? Or every one place to the right. So that is how we find the slope of a line if we're given 2 points. The other thing that we want to understand is something called slope-intercept form. And oftentimes students have heard this. They forget it's called slope-intercept form, but it's something that's in the form of y equals mx plus b, right? Where m is the slope. Put these, maybe recolor them there, right? So m is the slope, and b is the y-intercept. So we like it in this form because it tells us a lot of important information about that line. We know the slope of it, we know where it's crossing the y-axis when it's in this form. Okay, so I'll probably just do one more example here, and then we'll do some more next week to help you figure out, maybe some of the rest of Module 3. So on this one, if you're asked to identify the slope and the y-intercept. Okay. So we'll do a couple of them here. So part A, if we're given the equation y equals 1/2 x minus 5, right, then our slope is the number in front of our x. So x isn't part of the slope, just that number in front of it. And remember, that's only when it's in this form. We have to have it so y is solved by itself, right? We got y equals. If it's in that form, then we can pick out that slope really easy. So the slope is 1/2, and then the y-intercept is -5, but it's going to ask you to write this as an ordered pair. So remember, with a y-intercept, x is 0, and then our y is the -5. Okay? So that's what it wants you to do, identify the slope and the y-intercept. So sometimes it's already given to you in that form, but sometimes it's not, right? So let's look at one like this. So if I give you the equation, let's do -4x plus 2y equals 6. Right? And so we need to solve this, get y by itself so that we can figure out what the slope and the y-intercept is. Sometimes people look at this and they go, oh, that number in front of the x is the slope. It's not until we get it into this form. Okay, so let's solve this equation to get y by itself. So I'm going to start by adding the 4x over. So that's going to give me 2y equals 4x plus 6. And then I need to divide everything by 2. So then I'll have y equals 4 divided by 2 is 2, so 2x plus 6 divided by 2 is 3. And now that it's in this form, I can now pick out what my slope and my y-intercept are. So again, that is going to be my slope. All right, is the 2. And then the y-intercept is going to be 3, right? This is saying it's a positive 3. We always think that you need to know that sign in front of it. Know what that is. Okay, but again, we want to write that y-intercept as an ordered pair, so that would be 0, 3. All right, well, I hope that is helpful for you to understand some of these important concepts, the first half of Module 3. Please make sure to always reach out to me if you have other questions. Thank you.